Welcome back, everybody. My name is Vandana Saxena-Poria, and I am your guider of ceremonies for today. And it's a great pleasure to welcome Kemal Dorak, who's the Director of Quality for Vestas Denmark. Being the wind turbine leaders in the world, they're doing more than their fair share in ensuring that the world has sustainable energy solutions. But how have they embraced Industry 4.0? How are they using data digitalization and predictive models, as well as other solutions, to provide an even better, more scalable solution? Let's find out. So, Kemal, let's go to you.
Industry 4. Robots are talking to each other, lines are completely automated, human errors are eliminated, production line achieves the maximum efficiency and effectiveness, and many other incredible stories. We had been hearing this buzzword since years. However, we didn't know exactly what it means and how we can use it in manufacturing environments. Therefore, it triggered us to explore this buzzword more detailed and how to use it in reality in wind turbine assembly factory in 2018. I am Kemal Dorak from Vestas, Denmark. I have been in automotive and wind turbine manufacturing environment since 2007 in Denmark, in Germany, in Russia, and in Turkey. And I have been in Vestas as quality director since 2016. Before I start my real Industry 4 examples, I would like to introduce Vestas and wind turbine manufacturing briefly. Vestas is the world leader wind turbine manufacturing with the installed over 132 gigawatt in 83 countries, over 30 years experience. Vestas has also tens of factories in all over the world with the 29,000 employees. We manufacture, install, and service for customers with variety of onshore and offshore platforms like 2 megawatt, 6 megawatt, 4 megawatt, 10 megawatt, and finally, we are introducing the biggest and the most powerful turbine, 15 megawatt in the world. These giant equipment have several manufacturing processes like nacelle and hub assembly, blades, powertrain, which means gearbox, generator, converter, electronics, and software with a global supply chain support. After several Industry 4 investigations, we decided to be realistic and utilize the initiatives which fit to our business model. So, we decided to focus on big data, data digitalization, data analytics, IoT devices, and augmented reality. Today, I will give real examples from these initiatives in offshore nacelle and hub manufacturing factory in Denmark. We assemble 10 megawatt offshore nacelle and hub for our customers in this facility. Main processes are logistics, assembly, quality, test, and other support processes. Majority of assembly processes are manual with robot and automation support. This is a short information about Vestas and its one-off manufacturing facility. As you have been witnessing that the data has been guiding and controlling our life and business since years. Data-driven decisions are more important and crucial than before. Therefore, these decisions are more reliable than gut feelings. By the help of this awareness and trend, we started the digitalization in this factory. It was also the start point for this journey. Back in the time, majority of the records were captured manually in hard copies, and it was so difficult to collect, process, and analyze the data. It was time-consuming as well. Therefore, we decided to digitalize the manufacturing data by using the software and capture the digitalized data. First of all, we created the templates which is going to be stored digitally, and release them in the system for trials. Then we installed the computers and the mobile devices in the production and trained the people for the new system. The challenge was the resistance to change and to new unknown system by the employee who has been utilizing the old methods like manual recording. However, we started with pilot area and deployed it iteratively for the entire production step by step. First of all, it reduced the resistance and showed the advantages to employee. Then we achieved the implementation in a short period of time, like 6 months, by dedicated team. We started to collect the data, and by these collected data, we analyzed and defined the critical areas to improve. It also reduced the workload to collect, analyze, and submit to customer. Moreover, customer was also happy with the digitalized data, documentation, and improvements. Last step was to visualize the data in real time in the manufacturing to all employees. We created the dashboards and presented them on the screens in the factory to increase the data awareness and transparency. It was the first step for the digitalization journey, and we completely use the internal resources with minor investments and internal systems to implement this project. After we established the digitalized data, second initiative was applying data analytics over these collected data. After we collected the data, we were inspired by data science and its capabilities. It is capable to define the hidden patterns in data sets, create the predictions, and defining the critical parameters or features in the process. Therefore, we process the data by data science tools like machine learning or data mining and define the hidden patterns within the data, finding the critical points to focus and improve. By the help of this initiative, we defined the top cases and initiated projects to define root causes and corrective actions. For example, it reduced the test failures significantly, increased the overall effectiveness and efficiency, and increased the safety awareness. The challenge in these projects was the data quality and the lack of data science resources in factory. However, we improved the data quality over the years by training people, by motivating and showing the positive output of implementations, and also cleaning the data by data science tools. We also eliminated the lack of data science skills by using internal headquarter resources and university students. Bear in mind, data is useless and costly if you don't utilize it. Another initiative was augmented reality application in quality control processes. We assemble thousands of items in the production like weldments, castings, electronics, bearings, and many other commodities. Among these items, we inspect some of critical components and mainly by visual inspection. These visual inspections are carried out by qualified quality technicians. However, we were thinking about how to improve the efficiency and effectiveness of the process, and we came across with augmented reality technology. The idea was by using the AR technology, overlaying the original data onto real components virtually, and enables quality technician to compare components with original data. First of all, we developed the applications and integrated the applications to mobile devices. It is used as visual guide for quality technicians during inspections or engineers to analyze the cases. It reduced the process timing and increased effectiveness. Even though there were similar products in the market, However, we utilized internal resources to reduce the cost of implementation. We know that it's not 100% error-proof system and it doesn't capture the effects automatically. However, it helps employee to inspect quickly and effectively. Moreover, it has high potential to use for other areas like work instructions and trainings with wearable devices. Next example is IoT implementation for fleet optimization. We have tens of forklifts lifting fleet in the production. These are so crucial items in terms of high cost and production overall efficiency and effectiveness. And consequently, optimization is very important in order to achieve the best optimal cost and OEE. While we were thinking about how to optimize these fleet, we had an idea to install IoT devices on fleet to monitor and collect the data. First of all, we installed the IoT devices. These are basic GPS type of trackers, and started to collect the data to optimize. After we collected enough data, we had a chance to see the bottlenecks and the utilization percentage for each equipment. As a result of optimization, we had a huge potential of reducing the fleet number, which means cost reduction, and increasing the overall efficiency and effectiveness by the flow optimization. This application was one of the first unique type of optimization method in the wind turbine assembly as well. Return of investment was much higher than calculated, and implementation was also handled internally without extra efforts. This implementation is going to be deployed for the other factories in Vestas to achieve similar improvements and different equipments. Moreover, we have also close cooperation with university students and carry out common projects to support their thesis. For example, one of the projects was predictive maintenance for the cranes, and the idea was to assemble again IoT devices on the cranes, collect the vibration data, apply artificial intelligence to predict the failures in advance. Firstly, we again installed the devices on cranes and collected the data for 3 months. After 3 months, students analyzed the data and tried to create a prediction model by using AI. They completed their thesis by this project, and we had an idea and base how to implement the predictive maintenance for cranes in the future in production. Yes, today I try to give some real cases from wind turbine assembly factory. First of all, you need to be aware of that Industry 4 plug-in solutions may not fit all industries. Each industry has different dynamics and processes. We have 90% manual workmanship in the production, and 10% has consist of robots or automated solutions. Therefore, you need to evaluate your processes and customize based on this evaluation. You also need to consider the business case. If your business case is not positive, then it is not logical to implement any solution to just so-called to have Industry 4 tools. Of course, we haven't spent thousands of dollars for these projects. We utilize substantially our internal resources with minor investments. So, my advice is to try to utilize internal resources as much as you can and invest on your employee and inspire them to come up with creative ideas to solve problems. Let them ask, how can we do this better? Thank you all for listening me, and special thanks to organizers. I wish you a successful journey in your Industry 4 projects. Now, I will be glad to answer your questions. Thank you.
Okay, thank you and welcome back. And I have Kemal here with us now. So Kemal, look, thanks for a really interesting conversation that you had with us. I've got a couple of questions for you. You talked at the end about employees, right? And saying that they can really make a difference. How do you get them to embrace 4.0, Industry 4.0, and actually come up with the solutions? How do you do it?
Yeah, thanks again for the conference. And then, yeah, actually, I think that all companies, they have their KPIs, objectives, and then the question what we ask is, how we can make the things quicker, cheaper, easier, better, and safer. So that's why, and then we encourage our employee to think about this, the terms. And for example, for the safer wise, we encourage them to how to make the things to safer. So we came up with this the predictive the model, and then how we can make the things cheaper. Then we came up with this the IoT tools and the control the fleet. Yeah, and how we can things to make the things the quicker. Then we came up with this, the augmented reality in inspections. So.
And so that's what they did. But how did you kind of harness the energy of the employees to think in this way? Because this isn't a normal way that they would normally be thinking in. So you would have had to change the mindset. And that's something that Bhavan Mazumdar from Automation Alley talked about earlier. How did you actually do that? How did you help change the mindset?
Yeah, actually, of course, we presented this to what is the industry for, what kind of elements and how we can integrate to the manufacturing. As I mentioned, also, we have to be realistic. So we don't have, the robotic system, the full automation. So that's why we consider the options. So what kind of, the initiatives we can implement for the manufacturing. And then they came up with the ideas. So that's why we haven't embraced, all the initiatives like this, the 3D printing and then the other the models. So we were realistic and we analyzed our gaps.
So but one of the, the thing that you said you started with was you really educated them on Industry 4.0 and what is possible. So you told them what the art of the possible is, and then you said, what is it that you can do for us, or what is it that we can do that isn't going to cost an absolute fortune? Yeah, and that's what got them thinking. Okay, brilliant. All right, and how much time did it take for you to realize a return on investment with some of your Industry 4.0 investments?
Yeah, we had, of course, several initiatives, but approximately, I would say from 3 to 6 months, the return of investment.
Wow, so that fast?
Yes.
That's amazing. Okay.
Yeah.
All right then. Kemal, thank you so much for being part of Integr8 2021. We're going to give you a virtual certificate. We will be sending it out to you in your email. And in your honor, we will be planting a tree to say thank you very much for being part of Integr8 by IACC and also Automation Alley. So thank you so much for being part of this. Okay, great. All right, everyone stay with us. AI seems to be a buzzword, but AI is not a buzzword. We are going to be having a fantastic session with various members of a panel, and we're going to be talking about AI-powered manufacturing after this next break. Join in then. Please don't forget to answer the polls, and if you have any questions, please send them to us. Thank you, and see you in a couple of minutes. Bye-bye.